Caesar cipher, also known as shift cipher. This is a monoalphabetic cipher. This means that each letter in the message is replaced with another letter of the alphabet. This is an image of Julius Caesar. He invented a cipher called Caesar cipher. The whole purpose of him inventing a cipher was so that he could contact his military generals in the battle by sending a message. To reduce the chances of the enemy taking possession of the message and reading what had been written, Julius used his invention to encrypt the messages. During the transit, if the messages ever got caught by the enemy, the message is encrypted, which makes it unreadable. Only the general and Caesar know the key to decipher it. In modern times, this method is very easily breakable, since there is only 26 different keys. This is a simple method of encryption and decryption once you understand how it works. Using this table, with the top row representing plain text and the bottom row representing ciphertext. For example, if the key is 5, it is as simple as moving the bottom ciphertext row across like this. This demonstrates why Caesar cipher is also known as a shift cipher. Let's say Alice wants to send Bob a message. Hello world. Alice enciphers this message by matching the plain text letters in table to ciphertext letters. So H becomes M, E becomes J, L becomes Q, L becomes Q again, O becomes T, W becomes B, O becomes T again, R becomes W, L becomes Q, D becomes I. And now this is the ciphertext. However, this can be calculated mathematically as well, if you follow this encryption process. The encryption process is C equals M plus E modulo 26. And the decryption process is M equals C plus D modulo 26. C stands for ciphertext, M stands for message, E stands for encryption key, and D stands for decryption key. Caesar cipher encryption. Alice wants to send Bob a message, meet me. She creates a table like this and inserts plain text, numerical representation for plain text, encrypts as M plus E modulo 26, and ciphertext. The plain text message can go in the plain text row. The numerical representation for M is 12, E is 4, again E is 4, T is 19, M is 12 again, and E is 4. So Alice and Bob have agreed that the encryption key will be 3. Calculating is very simple. So let's start with the first letter M. The numerical representation for M is 12. To calculate the ciphertext, 12 is added to the encryption key 3. 12 plus 3 equals 15. 15 is the numerical representation for the letter P. This means plain text M is replaced by ciphertext P. Now apply this to all the remaining letters. E equals 4. Ciphertext equals 4 plus encryption key 3. So 4 plus 3 equals 7. 7 is the numerical representation for H. Again, E equals 4. So the ciphertext equals 4 plus encryption key 3. 4 plus 3 equals 7. 7 is the numerical representation for H. T equals 19. So the ciphertext equals 19 plus encryption key 3. 19 plus 3 equals 22. 22 is the numerical representation for W. M equals 12. So the ciphertext equals 12 plus encryption key 3. 12 plus 3 equals 15. 15 is the numerical representation for P. E equals 4, so the ciphertext equals 4 plus the encryption key 3. 4 plus 3 equals 7. 7 is the numerical representation for H. So the ciphertext for Meet Me is P, H, H, W, P and H. Caesar cipher decryption. Bob receives the ciphertext. The method used for deciphering this is simply a reverse of the encryption. A table is required with ciphertext, numerical representation for ciphertext, decrypts as C plus D modulo 26, and plaintext. The ciphertext message goes in the top row. Then add the numerical representation for each ciphertext letter. To work out the decryption key, Bob converts the encryption key to a negative number, so it becomes -3. -3 modulo 26 equals 23. Therefore, Bob's decryption key is 23. Numerical representation for P is 15. To work out what the plaintext letter is, we take the numerical representation of P, 15, and add it to the decryption key, 23. Using the modular arithmetic calculations for modulo 26, 15 plus 23 equals 12 modulo 26. 12 is numerical representation for M. Now to calculate the rest of the letters. H equals 7. To calculate the plaintext letter, add 7 to the decryption key 23. 7 plus 23 is 4 modulo 26. 4 is numerical representation for E. Again, H equals 7. To calculate the plaintext letter, add 7 to the decryption key 23. 7 plus 23 is 4 modulo 26. 4 is numerical representation for E. W equals 22. To calculate the plaintext letter, add 22 to the decryption key 23. 22 plus 23 is 19 modulo 26. 19 is numerical representation for T. P equals 15. To calculate the plaintext letter, add 15 to the decryption key 23. 15 plus 23 is 12 modulo 26. 12 is the numerical representation for M. H equals 7. To calculate the plaintext letter, add 7 to the decryption key 23. 7 plus 23 is 4 modulo 26. 4 is the numerical representation for E. So the ciphertext has been deciphered into the plaintext message, Meet Me.